13th June GFG question. Somebody is eating bananas. We're given an array and a k variable that represents hours. So basically we have to finish these much bananas in 8 hours at max. And we have to return how many minimum bananas should we eat within an hour in order to eat all these. So basically the condition is, suppose you're eating 7, right? 7 per hour. So these four are basically piles. You cannot move away from one pile to another pile in a single take. For example, you started eating this pile, so you can eat this entire thing in an hour because you have the capacity to eat 7 bananas per hour. So you can definitely eat at least 3, right? So next you move to 6. You can also eat 6. So the amount of hours you took to eat these 9 bananas is 2 hours. Then you can move to third pile. You can eat this also because you have the capacity equal to, right? You should have the capacity greater than or equal to, right? Next, for 11. Now you cannot eat all this 11 in 1 hour. So you cannot finish the entire pile in an hour. So basically you have to break these 11 down. Like you can eat 7 bananas in the first hour and then you can eat 4 bananas the rest in the next hour. So basically if you have the capacity of eating 7 bananas per hour, then you will require 5 hours in order to eat the entire array. So basically then you have to determine how less capacity, like 4 or 3 or 5, how less capacity is able to satisfy this condition that we can also eat all these and we also do not exceed the amount of hours that we are given. So that is what we have to find out. For example, let's take another example. You are eating only 2 bananas per hour. So how many hours will you take to eat 3? You will require 2 hours, right? In the first hour you eat 2, in the next hour you eat 1. Similarly, for this 6 you will require 3 hours, so that makes the total of 5. For this you will require 4, so that will be 9. And for this you will require again 6, so 9 and 6, 15 hours. That is exceeding our value of top limit 8. That's why we cannot return our answer that the capacity is 2 bananas per hour, right? We have to move upwards, right? We have to search for whether we can do it 3, whether we can do it 4. So the answer of this one is 4 actually. We'll see how it is 4. So first, let's think, what is the maximum value that we can return as an answer? If you know one rule that we cannot move from one pile to another pile in a process, right? We cannot move between piles. So even like suppose the maximum value is 11, you have the capacity of eating 11 bananas per hour. Then the amount of hours that you will require is 4, right? Because you can finish each pile in an hour, right? You cannot do anything less than that. For example, the capacity is 11,000, right? Still it will require 4 hours for you to finish because you cannot move from pile. So the maximum value that we can return as our answer is 11. And what is the minimum value? There is no way you can eat 0 bananas, right? You will end up in an infinity loop if you try to check for 0 bananas, right? So the minimum value that we can return is 1. So that is what I've written here. The minimum possible answer can be 1, and the maximum possible answer is the maximum value of our array. So we have to find answer between these range, and whenever we are given that we have to find an answer between a given range, we have to think of binary search. So basically we are going to do binary search between these values. This is our start, 1 is our start, 11 is our end. We have to search in a binary search, like we will determine the mid value, which is I guess 6, and we will check 6. What is 6? 6 is basically our capacity, 6 bananas per hour. So we will check, we will do a linear traversal for this 6 bananas. We will check that whether it is possible to satisfy the given conditions for 6. Is it true? Then 6 would be our candidate, right? 6 can be our possible answer. But since we are given that we have to find as minimal answer as possible, we will move our end from 12 to 5. That is basically 6 minus 1, right? So then we will search from 1 to 5. Right here I've also written some dry run. So you can see first the mid value would be 6. Then the time needed would be 6. How this 6 came? So basically you can eat 6 bananas per hour, right? So you can eat this one in an hour, this one in an hour. 7 requires 2 hours, right? 6 plus 1, 7. And this requires also 2 hours, 6 plus 5, 11. So you will need 6 hours in total. So is it less than our 8 hour of top limit? Yes, it is less, right? So we will try someone with smaller capacity, right? This is our answer candidate. We will definitely store 6 and our answer variable, and we will move to the left. So basically our new mid would be 1 plus 5 divided by 2, that is 3. then we will check for 3 bananas per hour. Now the time taken for this one is 10, so that is exceeding our top limit, so that is why we have to move towards right direction. So next we will perform the searching between 4 to 5. So if you take the mid of this, it will be 4, since right the division is of floor value by default. So the mid is 4, we will check for it, and we will find that the time taken is 8 exactly. So that is less than is equal to, even if it is equal, that is fine. So this we will store 4 as our candidate, and we will move the search from 4 to 4, right, basically. And then this will again search, since we are doing the binary search. If you have written less than equal to condition, it will again go for one loop and then it will end, otherwise it will end directly. It doesn't matter, but we have our answer stored as 4. Okay, so the thing is, how do we determine, like we are given 6, right? How do we determine the amount of hours? It's a very simple formula. You can either perform this ceil function of division, or you can write manually, like count plus is equals to, you can write like, suppose I divide by this mid value. What is I? I represents the value of array, and mid value is basically what we are checking for, like 6. So 3 divided by 6, what is it? It is 0. That means our number is less than our capacity, right? So we do not require anything, but we have also to do this. I modulo mid doesn't equal to 0. So 3 modulo 6, it definitely is 3, and it doesn't equal to 0. That is why we will add 1 to our count. So basically, like for this one, we get 1. And for 6, we can check what is I divided by mid. 6 divided by 6 is 1. So we are adding 1 to our count. And for the next one, 6 modulo 6 is 0, right? So we don't have to add 1 in this one, right? So this will basically ensure the accurate calculation of the amount of hours that we require given a particular meet. So here is the code I've written. This is simply the size, the starting and the ending. I have iterated over the array in order to count the maximum value. If you want to eliminate this iteration, what you can do is you can check the constraint also. Like here it is given 10 raised to 5. So 10 raised to 6, right? The value at max can be 10 raised to 6. So you can hard code the end to be 10 raised to 6, right? If you want to eliminate this loop, but I don't think it is that much. So I have calculated the maximum value. Then initialize an answer variable. This is simply a binary search. Here I'm checking validate function, whether this particular mid satisfies our condition. If it does satisfy, it will be candidate for answer, and we will move to the left. Now in the validate function, I've exactly done what I just explained, right? And we will return that the amount of hours taken with this mid is less than is equals to k to satisfy our top limit. All right, you can submit this. You will find this code in the GitHub, right? Thank you.